Okay, so in this video we're going to do question number 19, and it's basically finding the vector product, the dot product and the cross product. So this is question number 19, I think. So we're given two vectors. Here's the first vector, A, and it has a value of 2i plus 3j plus minus 5k. Okay, so minus 5k. And we're given B vector. B vector is 1 minus 2 minus 1. So 1i minus 2j minus 1k. And I hope I got those numbers correct. And so we're actually asked to find the dot product. And remember, there's two definitions of a dot product. So I'll go through both definitions right now just to make sure. So the vector dot product of two vectors is, one definition assumes that we just take the, actually let me generalize this over here. So if somebody gives you ax, if a vector is equal to axi plus ayj plus azk, and b vector is equal to bxi plus byj plus bzk, then the vector dot product a dot b is going to be equal to this two definition. Definition number one is we just take each of the products of each of the directional vectors and just add them up so as a number. So these are scalar values, and bx plus ay by plus az and bz. That's definition one. It's also equal to a dot b. The second definition is equal to the magnitude of the a vector times the magnitude of b vector times cosine of the angle between them. So any two vectors, if you put them tail to tail, they form 3 points in space, and that defines a plane. And so in the plane, right, they form an angle theta. So if you're given b, so both definitions are identical. You can prove one to the other, and so you have to know what the dot product is. Here in this case, we don't know the angle between the two vectors, so because we don't, right, we're going to go with, we know the magnitude of A, we know the magnitude of B, but we don't know what the angle theta is. So I'm going to go with the first definition. The first definition is going to be 2 times 1 plus minus positive 3, times negative 2, and plus negative 5 times negative 1. And actually, I would prefer if you actually left it in this form without actually calculating the number, because at least I know exactly where everything's coming from. Again, I'm testing you on your ability to understand and how to apply your mathematical rules and physics. So I need to know where everything's coming from. So your exams. Okay, so you should be able to just write this. So I'm not even going to calculate this. That's 2 times 1 is 2, and this is negative 6. So this is negative 4. Negative 4 plus 5 is 1. Sorry, negative 4 plus 5 is, 1. Okay, so that's the dot product. So we're going to do the cross product again. The way that there's two definitions for the cross product. So if somebody gives you two vectors A and B, and the reason we have to use cross products, right? Cross products actually only work in 3 dimensions, and we need something better and stronger, but the problem is that well, anyway, it's ingrained. Cross products are ingrained in our math and physics classes, so we have to teach it this way. So you'll see it everywhere in terms of torque, angular momentum, magnetic fields, forces across charges moving through magnetic fields. So you'll see torque everywhere in 3 dimensions. Okay, but it's not very good because it only works in 3 dimensions. So anyway, here is the cross product, definition number 1. So we can say it is the determinant of a 3 by 3 matrix consisting of I, J, and K, and you put the first set of elements, which is AX, AY, and AC, and BX, and BY, and BZ. And the second definition is going to be equal to, so this is A cross B. So much like a dot product, there's two definitions that you have to know, and you can prove one definition to the other, going back and forth. And the second definition is that it is the magnitude of A times the magnitude of B times sine of the angle theta between them, between the two vectors, and times a normal vector. And I didn't actually, so we started right-hand rules, right? This right-hand rule for cross products that, so this is the vector that uses the right-hand rule that's perpendicular to both A and B. So if I could draw this out, so if A is this and B, and this is a B vector, so A cross B is a vector that's turned this way. So A turns into B, so I'm going to use the right-hand rule by using my fingers, my four fingers, not my thumb, and I turn in the direction from A to B, and my thumb points in the direction of the cross product. And so the cross product is going into the board, so I'll put a little X like this, and saying that's the arrow going into the board, and this is your cross product. It's not, you don't have to know it for this the second exam, but you do have to know it for the final exam. Okay? So we have to use the right-hand rule for the final exam because we're actually doing calculations with magnetic fields. Anyway, so we don't know what the angle theta is anyway, so we can't use the second definition, so we're going to go to the first definition. So we have to calculate the determinant. So I'm going to calculate A cross B. Am I on the board? Yeah, I'm still on the board. I'm on the screen, right, just to make sure. So this is the determinant. So this is a vector I, J, and K. And here's your components 2, 3, -5. And this is 1 and -2 and -1. Okay, so how do I calculate the determinant? We can take any row or column, so it's quite arbitrary, but this is a, so there's not a lot of zeros, so you know, you would expand around a row or column with a lot of zeros. So if there's 2 zeros somewhere, right, try to use that column. There's 1 0, try to use that row or column corresponding to it. But we don't have any, so I'm just going to do a regular expansion. I'm going to expand around the IJK column, sorry, the IJK row. And remember, our sign matrix is going to be a plus, minus, plus, minus, plus, minus, plus, minus, plus. Okay, so that's our sign matrix. And so let's go through the expansion. So I is the first element. And what's the sign of I? It's +1, so I'm going to put a +1 here. And then we have to take the minor matrix. The minor matrix is take out the row and column associated with the I, this row and this column, and we have to write the determinant in terms of the minor matrix. So the minor matrix, right after removing the ith element, the minor of I is 3, -2, -2, -1. And then we have the next element. I'm just putting diagonally, if you don't mind, because there's not enough space to go run across. So the next element is J. The sign of J happens to be a -1, so I'll put a -1 over here. And then we do a determinant of something smaller, the minor of J. So take out the row and column. Take out the row and column. You're left with 2, 1, -5, and -1. So 2, 1, -5, and -1. And then we have another matrix, K. So we're expanding a linear set of elements, K. And K is, the sign of K is +1. And we take the determinant of, take out the row and column, you're left with 2, 3, 1, -2. 2, 3, 1, -2. And so, actually I do have to erase this, so let me erase this. And so I'll say that this is equal to, so the sum of these three elements, the first element is going to be +1, and I'll say this is I, and I'll put a square bracket. So whenever you have a 2 by 2 matrix, remember the rule is that we take the product of the principal diagonal and minus the product of the off diagonal. So this case, this would be 3 times minus 1 minus, and then there's a negative 5 times negative 2. Hopefully you saw that. Okay, 3 times minus 1 and negative 5 to negative 2. And then the next element is going to be a plus times minus 1 times j. Don't try to reduce these because I don't really care about the answer. I'll be checking your exams in terms of being able to see the procedure for constructing these vectors, okay? I don't care about the answer. And so remember, I'm one of those people that actually likes to make sure you understand the idea. J, this is 2 times minus 1 minus negative 5 times 1. Okay, so the product of 2 times minus 1 minus 5 to 1. Remember, this is a minus. And then there's the last element is going to be plus 1 times k. And then it is 2 times minus 2 minus 3 times 1. So again, 2 times minus 2, the principal diagonal, subtracted by the product of 3 to the 1 diagonal. And I would just leave it at that, so because I'm not really checking the answers, I'm always checking your steps in constructing the answer. So remember, it's not a multiple choice exams. I don't give multiple choice exams. I give exams to make sure you're understanding an idea, a process. Okay, so this is question number 19.